This video is going to cover the topic of solving inequalities with negative coefficients. Be sure the date and topic are at the top of your page. The essential question asks, what happens when we solve inequalities with negative coefficients? And we have already seen that solving inequalities is very similar to solving equations. However, this video is going to show us something that looks a little different. I'm going to start here with a one-step inequality as an example. And I want to point out that this inequality has a coefficient of -5. So this is a negative coefficient. This is what's different here. So I'm going to start just by doing this as normal, right? I'm going to divide by -5 on both sides, since that's the only operation here. And then I would get something like h is greater than -2. Or at least I think so, but I'm going to check this. So I've selected a number that is greater than -2. -1 is bigger than -2. And if I test this out, -5 times -1 is 5. And if I finish writing this, I would say that 5 is greater than 10. But this, of course, is not true. Choosing a number that was greater than -2 and plugging it back in did not get me an inequality that was true. 5 is definitely not greater than 10. This cannot be the answer. This right here that we thought was our answer must not be true. So here's what we have to do differently. A funny thing happens when we divide or multiply by a negative number when we're solving inequalities. We actually have to reverse the inequality. So here I am dividing by -5 on both sides. And I get h, and I get my -2. I need to actually flip my symbol. So instead of being greater than, I'm turning this around to be less than, which means I would read this as h is less than -2. And I'll check it this time by picking a number that's less than -2. So how about -3? And we'll see when we put that in if that satisfies our inequality. -5 times -3 is 15, which is indeed greater than 10. So now this works. This is our solution. So that's the big rule. When you divide or multiply by a negative number, meaning the coefficient has a negative with it, you need to flip your inequality. We'll do another one-stepper. We'll try -7k is less than or equal to -28. And of course, this is just one step, and that one step is to divide, but we're dividing by a -7. So remember that you're dividing by a negative integer. When you get that, of course, you would find that k is left by itself on one side, and this would be 4 on the right-hand side. But I need to now flip my inequality. So instead of being less than or equal, it's going to be greater than or equal. I am flipping my inequality, and we'll test it to make sure that is, in fact, the way to satisfy this inequality. I'm going to choose a letter for k that is greater than or equal to 4. I'll just pick 11 here, why not? And I'm going to fill this in, and I'm going to solve. And 11 times my -7 would give me a -77, which is definitely less than or equal to, in this case less than, -28. It worked. And as with all inequalities, I'm going to go ahead and graph this to show all the possible solutions. It could be 4 or anything greater than 4, like 11, that would make this original inequality true. The same is going to be true of a two-step equation, right? So I have -3x plus 5 equals 26. And notice, right, we have this negative sign in front of our coefficient, right? So we're going to kind of keep that in mind as we go. We can go ahead and solve this as we normally do by, of course, subtracting the 5 from both sides and getting -3x, right? We're still just as we were before, is greater than 21. But now we're going to be dividing by a -3, right? That's the important part. So I'm going to end up with x over here. I'm going to end up with -7 on this side, but now I need to make sure that I flip my inequality. So I'm going to flip it to less than rather than greater than. And if I did this correctly, then I should be able to check my work by choosing any number that is less than -7. Let's go with -10, friendly here, to fill in. And I should be able to say at the end that I know my answer worked. And of course, if I do this all the way through, 35 is definitely bigger than 26. So by choosing a number that was that was less than -7, it worked. And I'll always end by graphing my solution, so I know that it couldn't actually be -7 to make this right, but anything that is less than -7 would be a solution to this inequality. You could think of this like most algebra, like you're solving a puzzle. So I could say I'm thinking of a number that when multiplied by -3 is less than 15. So I could say that I know that I have a number and I'm multiplying it by -3 and it has to be less than 15. So I can try to figure out what my number should be. Well, let's solve for what n could be. So we know that we have n on this side and we have -5 over here, but because I was dividing by that -3, I need to flip my inequality. So maybe my number is anything that is greater than -5. And I'll just check and pick a number that's greater than -5 that maybe could be that mystery number. So we have -3 and we could do, our number could be anything that's greater than -5. Let's say -2. And of course, we're just going to fill this in. -2 times -3 would be 6, and 6 is less than 15. So maybe my mystery number was -2. However, right, really it could be a whole bunch of things. As long as it is more than -5, it could be an infinite number of solutions. So that'd be a tricky puzzle for you to have to guess, since it could be an infinite number of options greater than -5. And I'll leave you with one more to try on your own, just the inequality here of -6y plus 2 is less than 16. So you're going to solve that and figure out what y could be, and of course you'll also graph it on your number line. So remember that the essential question for this video was what happens when we solve inequalities with negative coefficients, and we have seen that we have to flip that inequality when we divide or multiply by negative numbers.